Thank you for joining today's webinar. You are in the lobby. The webinar will be starting soon.
Carl, you might want to cut your video.
Thank you for joining today's webinar. You are in the lobby. The webinar will be starting soon. Thank you for joining today's webinar. You are in the lobby. The webinar will be starting soon.
Good evening. My name is Andrew Dodd. I'm a member of the IET Bucks Committee. It's my pleasure to welcome you to tonight's webinar, Holes and Poles, or perhaps more properly, fibre to the premises. I know there are one or two people still joining, but I'm just going to start giving the introduction now to the event. Some housekeeping rules. If you want to ask a question, can you do it via the Q&A facility at the bottom of your screen or alongside on the sidebar? There is a voting facility within the Q&A mechanism of Zoom. So if you like a question that somebody else has asked, could you add your "I like it" and what I see, and you may well see as well, is a thumbs up and a number beside the thumbs up, which will tell you how many other people are asking the question. When Carl delivers his talk, it'll take about 45 minutes, and then I'm going to moderate the questions based on what I see on the Q&A. I will be monitoring the chat line as well, but if you can ask questions in the Q&A. One bit of IET housekeeping. The IET is currently undertaking a body of work to better understand the needs of the IET's audience and its characteristics, and how well you think you're being represented by the IET. At present, the IET does not have the data to enable it to fully understand where the organisation needs to improve. So there is a survey has been launched, which will run through to the end of 2021. What I will do is on the chat line, I will put the URL to this survey, and if you can enter into it, please do so, and thank you very much indeed in advance. So I will be putting up the URL in the chat line at the moment. This evening, there is also has CPD. There's a CPD certificate like this. I will put that on the IET Buckinghamshire web site shortly, while trying to listen to Carl at the same time, which hopefully I'll be able to do. And I'll put it up there. And again, I'll put the URL in there. If you want to find it without using the URL, if you go to just Google IET Bucks events, that will take you through to the IET Bucks homepage. And if you look on the right-hand side of the web page, you'll see files, and the CPD certificate will be attached in files. I may also put it in the blog. That seems to be more popular. So certainly in the files and also in the blog as well. This event is being recorded, and the recording will be uploaded in about 3 weeks' time, again to the Bucks IET website. So it's just a matter of keeping a lookout for that if you want to join in. Just looking ahead, we'll have one more event before we have a summer break from webinars from Bucks, and we'll be having a talk on how you can apply for Chartered Engineer. This will be given by Rob Wright, who's one of the IET's professional registration advisors. He's delivered the talk before. He's very knowledgeable about the PRA process. He takes PRA right up to fellowship and knows everything that you'd want to know about how to become CEng. So that date hasn't yet been agreed, but it will probably be late June, early July. So if you are interested in that, just keep an eye on the IET events page and that will crop up. Right, it's my pleasure to now introduce Carl Pimblett. Carl is a fortuitous discovery. We have had a number of talks from Phil Corbishley over the years, looking at the next generations of telecommunications. I think we started with 4G, 5G, and Phil tells me he's preparing a talk now on 6G, and that's before most of us haven't got beyond 4G. Anyway, we're hoping to have Phil live, and by live I mean actually in a room in late October at our usual venue, the Bucks New University main campus in High Wycombe. Hopefully Phil is on the call, and maybe he can put a hand up and just confirm he is on the call. But I was speaking to him and saying, well, look, what it would be nice to have a talk about, what does it actually mean, fibre to the premises? What's behind the technology? Do you have a box on the wall? What do you see as a, you know, it's there as a white box? You know, what do you plug into? How do you connect it to your home system? And he said, well, I've got this friend called Carl, and he's an expert on this. They've done a lot of things. So Carl suggested that we perhaps call the talk Holes and Poles, which I thoroughly agreed with, because he said a lot of the problems for getting fibre to the premises is, guess what, is making the trenches or putting wires down the poles. Carl spent more than 35 years in the telecommunications industry, working first at Plessey, GEC, Marconi, followed by Hawaii and ZTE, initially as a design engineer, and then going through product marketing, pre-sales, technical solution direction systems. He's now technical director for 3ITEE, providing professional services and consultancy across a wide range of telecommunications issues. Anyway, with no further ado, I'd like to hand you over to Carl for tonight's talk.
Right. Well, thank you very much, Andrew. Hopefully you can see my slides. Thank you very much for inviting me. Pleased to be here. As Andrew said, I'm here to talk poles and holes. More specifically, I really want to talk about briefly the technology and the challenges of building full fibre networks, and what does full fibre really mean? And specifically looking at the additional challenges of delivering this in rural areas for those unfortunates who have been suffering for quite a long time. So the agenda I'd like to go through is, first of all, touching on what is the environmental changes that's generated this this push towards full fibre build. Look at where we've come from in terms of existing broadband technologies evolving through to full fibre, and then touch on first of all, the active or powered electronic components in the network that deliver the broadband service, but also the passive or unpowered fibre optic components that most people don't really see much or understand much about, that actually deliver the fibre optic service to the end user. Once we understand the components and the technologies, I then want to talk about the civils infrastructure that is deployed on, so the poles and the holes that host all this equipment, and then how we actually deliver it, the organizations involved, participants and the processes, and how we actually build and deliver a working service. So that is the topic for So first of all, the good old PEST, political, economic, social, and technical, really starts from the government having an imperative to be top of the class in Europe, I think, in terms of the ability to be delivering super fast broadband along with the best across Europe, trickling down to regulators working with Openreach, BT, in order to facilitate more competition, and we'll talk about what that means, but also creating an organisation called Broadband Delivery UK that can act as a funding element for government subsidy to help the economic model in terms of delivering outside of the urban city centres, the harder to reach, more expensive to reach areas, and also local governments wanting to support this to help with the economics in the environment. This, at the same time, in the competitive cycle, investors, as soon as they understand there is financial assistance that assists their business model so that they can extend the reach and the potential customer base, they will automatically participate and help to fix this UK digital divide problem that we've had, where low tele density, that is the small number of properties within a given distance, make it very expensive to deliver high-speed broadband. In terms of social aspects, we all want faster broadband, and we know the advanced applications, particularly if you've got children into their gaming, how important this is. But certainly teleworking has come to the fore, obviously, in the last 6 to 12 months. So that's a key driver there. And then finally, bringing this all together and then enabling this to happen is where we were reaching the limits of copper technology elsewhere in the world. Other countries, particularly in Asia, have been pushing fibre delivery, which has increased global volumes and reduced the cost points for silicon and various technologies so that vendors can offer more attractive cost points to support the business model. So these are the drivers that have made a big change in the last 18 months to 2 years. So first of all, the broadband technology path. We started with the first generation of broadband, as you probably all remember, with a thing called ADSL, which was a point-to-point delivery of broadband over the copper wires for the telephony service. It was delivered by having a thing called a DSLAM, a digital subscriber line access module, powered equipment in the exchange that delivered digital signals at a higher frequency than the voice service on the same copper to be terminated on the modem, modulator demodulator that you'll be familiar with in your home, which is integrated inside the router. But there was also a little dongle that sat in the telephone socket to split the frequency bands into the pots and the digital data that you see in the spectrum at the bottom left. So there's an upstream frequency bands and the downstream frequency bands. Now, the key thing about the delivery of these digital signals was the higher the bandwidth demand, the higher the frequency you needed to push down the line. If you have very long lines, the high frequency signals don't reach far enough. And if you can see bottom right, the original ADSL 8 megabit service, if you were not within 3 kilometers of the exchange, you got a rapid drop off in your throughput. And for ADSL2, when that came along, 24 megabits, we were very impressed with this. But if you weren't within 1 kilometer of the exchange, you weren't getting the maximum service. So there was then a push to solve the problem of the distance. And this is where you started to see 10, 15 years ago, green cabinets sprouting up in the street, where the DSLAM electric equipment that had previously been in the exchange was pushed out into the streets, into the cabinets. And that injected the higher frequency digital signals that you see in the spectrum at the bottom, going up to 12 megahertz. They were injected on the much shorter distance because the cabinet was closer to the home. So shorter means faster, So you can see on the middle left, there was a VDSL1 service and a VDSL2 service that gave approximately 50 megabits and 80, 90 megabits per second, depending on how close you were to the exchange. And as you can see at the bottom, if you were less than a kilometer, you could take the VDSL1 service. But to benefit from VDSL2, you needed to be within 300 meters of the cabinet, and that's powered equipment. So you need it everywhere. And it's still using the legacy copper wires that go back to the exchange. So this was limited to urban areas and couldn't be deployed in rural areas. So the next step was to bite the bullet and deploy an alternative to the copper that had been there for decades and put in the exchange what was called an optical line terminal, which delivered a number of wavelengths in the up direction and down direction on a single fiber from the head end in the exchange in urban areas, which could reach far, far greater distances than DSL, up to 20 kilometers for typical services of PON. But this was a multi-point service. That is, the single fiber would deliver to multiple homes at the end, because we could deploy optical splitters closer to the home and divide the laser light signal to the devices and multiple properties and improve the economics. That's a typical urban BT deployment. The alternative operators that wanted to reach further out or build where BT weren't would take a similar approach to that of the fiber to the cabinet service we talked about with VDSL, by moving the optical line terminal into a cabinet in the street and power that closer to the rural areas. So you could have a long distance of backhaul from the exchange to a street cabinet in a rural area. And then, because you can reach potentially up to, let's say, 20 kilometers, imagine the cabinet in the center of a radius of 20 kilometers. So that is quite a large geographic area to be able to support. But the passive optical network requirements are slightly different to that in urban areas, as we'll explain later on. So just to touch in a little more detail on the active components that we just spoke about at each end of the fiber optic chain. First of all, there are different flavors of passive optical networks. The original technology back in the late 90s, which was based on ATM, APON and BPON, didn't really take off. And it wasn't until the early 2000s that two standards came out, one from the IEEE, who are very Ethernet focused. They drive the Ethernet standard. So they came out with a technology on the fiber called EPON, which was literally raw Ethernet, or very close to an Ethernet signal on a fiber, point to multi-point on a fiber. But the ITU-T, who drove a lot of the standards for the telecoms operators, came up with an alternative called gigabit passive optical networks, which was higher speed, 2.5 gigabits down, shared across a number of users, and 1.25 gigabits up. That was also designed to not just support IP type data with Ethernet framing, but also could have coexistence of TDM services to support legacy services. And that's where the ITU-T were driving. That's not the case now. Nobody uses that technology. It's all based on Ethernet and IP delivery. Moving on to 2010, we see the 2.5 gigabit service moving to a 10 gigabit service. And then in 2015, moving to a symmetrical version where the 10 gigabit service XGPON was 10 gigabits down and 2.5 gigabits up. In 2015, we had new technologies for symmetrical 10 up and down. And that is probably where most customers are being delivered as business customers, albeit you can have coexistence of 10 gigabit PON and GPON on the same fiber, and we'll talk about that a little later. So This is the delivery of PON in terms of the technology. We have the cabinet, the OLT, multiple fibers coming out of the cabinet in various directions. So think of it in the middle of a cake, and the various fibers are feeding out in different directions to be able to deliver 360 degrees around the cabinet. The optical splitters delivering to multiple homes. And in the home, you have, as a service provider, a choice of what you want to offer. You can either just offer a data service where you have your typical router connected to a device which is terminating the optical service and just delivers a broadband only service. Now for telephony, you still need the telephone copper wires to take a POTS service. But an alternative is that the optical network terminal, the ONT in the home, could also have an analog telephone port for your legacy telephone to plug into, and you deliver the telephone service as voice over IP. Now, what's happening on the fiber here is, if you look top left, just as in radio, as in mobile radio, FM radio, there is a spectrum, a range of different frequencies. And in this case, it's no different, because after all, light is just electromagnetic waves. We are putting multiple wavelengths in different directions so that there isn't any contention. And the GPON and the XGPON service have been specified to work on different wavelengths so that they can coexist on the same fiber. Top right, you see a table of the speeds down and up, the maximum number of ONTs that can be terminated on the end of a fiber tree, and the typical number based on the distances that you actually want to achieve as compared to the maximum that theoretically can be achieved. So that's the technology for the active components. What about the passive components? Between the head end and the home, there are a number of different devices that manage the delivery of the optical service over the fiber. In the cabinet, there is a thing called an optical distribution frame, an ODF, that allows you to interconnect the laser connections on and the receiver connections on the OLT and flexibly connect them to the cables, the multiple fiber cables that are coming out of the cabinet in various directions. And this allows you the benefit of flexibility in terms of configuration when you want to change capacity and port density, where you want to fix problems with maintenance with dead ports, various reasons you need the flexibility of the frame. Further down the network, when you want to take high fiber capacity cables and split those fibers down in different directions, you need to be able to splice or fuse one fiber from one cable to another fiber on another cable. And that's what a splice closure is for. So you can see on that picture top right, there's cables going in on the base of the unit. You can see the fibers routing round and bending so that they don't break onto those little flat units with the orange tape round. Those are where the fibers are spliced together to connect any one fiber from any cable to any cable. In addition to that, we talked about the optical tree, the optical splitting tree, where we're taking one fiber and splitting into multiple fibers to improve the economics. So what you can see bottom left is the implementation of an optical splitter and an example of a device that will be put inside the splice closure. So not only do you splice fiber to fiber from one cable to another, you might splice one fiber to a device that is delivering the service to individual ports on the top of a pole or in a chamber to homes, which is where we come to the distribution point of device bottom right. So this is taking 2, 4, 8, 16, 12 fibers from the splitters in the splice closure and delivering them to connectors on the distribution point device, where you can, at some later stage, connect a drop fiber cable to the property. So you're not forced to deliver the fibers at the beginning of the build. You can do it dynamically as and when customers demand service.
Carl,
yes,
I apologize for interrupting you. I've had a number of requests. what we're seeing at the moment is your main slide, and then next slide is your PowerPoint in full scale mode, or
It is on my screen.
okay. I think there's something which I'm afraid it's obviously something to do with Zoom. I apologize for interrupting.
Okay.
There's what we're
But
seeing is
you can see the main slide.
I can see the main slide, but I'm also seeing your next slide. So
Right. Okay.
it's jumped itself to a funny mode, but unfortunately I don't
Okay.
know how to advise you. I was hoping you'd say it was PowerPoint. I apologize for interrupting.
Okay. Here we have a diagram of how the infrastructure of the cables and the closures with the splitters build up a distribution tree between the cabinet and the distribution nodes that are going to finally drop an individual fiber to a home. So you'll see the red cables we refer to as the spine or backbone feeder cable from the cabinet to the first closure, where that may connect to a continuation of that backbone to other closures in the main route direction, or it may select some of the fibers in that backbone and splice them onto what we call lateral or spur cables, which go off left and right directions to broaden the footprint as we move out from, if you remember, think of the cabinet in the center of the cake, and we're trying to distribute to the whole of the cake. So actually each backbone spine fiber can feed a slice of the cake, and as it gets further and further down the cable, it can deliver to a broader footprint. So that's the splice closure, the splitters in the splice closures, and the DPs at the edge of the network connecting to the properties. And that passive infrastructure we call the optical distribution network. The cables that we use are a number of different types based on the application, but they all use a common fiber technology within the cable, which is specified by the ITU, I think it was 657A1, which is a grade of fiber that's optimized for fiber to the home, because it allows you to bend the fiber far more than normal trunking fiber, which is really important when you consider you've got to bend the fiber round at the tops of poles, in chambers, round bends, through walls into properties. And the further you bend the fiber, the more attenuation you introduce, which is really important. So we have three different cable implementations or technologies to deliver based on where they're going. If they're going in ducts, we use a cable construction called loose tube cables, which is optimized for use in ducts that have to be pulled through the ducts over long distances between chambers, potentially using cable ropes to pull them through. Alternatively, if this is a cable that's going between telegraph poles, it has a different set of parameters based on the fact that it needs to be light, it needs to cope with the weather conditions, particularly windage. And so we have an alternative technology called ultra lightweight, which for certification purposes and being allowed to be used on BT's passive infrastructure, the poles and the holes, they limit this cable type to either 36 or 48 fiber, whereas the cable in the ducts can be any number of fibers, typically 48, 96, maybe 144. Each of the fibers is color coded and tends to be bundled up, usually in groups of 12 that go in a tube or an element that itself is color coded. So no matter how many fibers you have in the cable, from the color of the fiber and the color of the tube that the fiber is in, you know the identity of the fiber because it's too small to put any identity on. Finally, there are parts of the infrastructure where you don't have access to ducts, you don't have access to poles, or you need to connect between two exchange areas, or you need to go underneath power lines. So you need to bury the cable, and hence you need steel wire armed cables. So these are three different technologies. We've talked about the splitters, but it's a little bit more involved than we first suggested, because there are a number of different configurations that can be used to optimize it for the application. In urban areas where the properties are very close together, if it's a GPON 2.5 gigabit service, although the architecture and the addressing on the fiber supports up to 128 devices at the end of the fiber, that's actually too many devices to spread the 2.5 gigs across. And typically, it will be 32 homes or 32 optical network unit devices in the home that are connected to the splitter. But that's one splitter closely located to all the properties in an urban area. Where you have rural areas, you don't necessarily have 32 properties within the logical drop distance of the cable to get you to the DP, and then the drop cable from the DP to the home. So you might introduce a 2-layer splitter architecture of a 1 to 4 optical splitter feeding 4 1 to 8 optical splitters that can be geographically spread out, but you're still delivering the service across 32 properties. And then finally, another example here is where 10 gigabit PON, you might, your business model might say you want to deliver 64 properties with a 10 gigabit service, but you know in the future those customers want to take higher bandwidth. And so what you might do is put a 1 to 2 splitter in the head end, actually in the optical distribution frame that can be reconfigured later, and initially deliver all 64 properties from one fiber, one laser on the OLT. But then later, when you want to double the capacity to each property, you just take out of circuit the 1 to 2 splitter and connect the 2 feeder fibers onto 2 separate ports on the OLT, which is a very, although it interrupts service slightly, it's a very easy way of increasing capacity significantly. Another important thing that I want to talk about is the optical budget. We talked about 20 kilometers distance, but actually it's not that rigid. It's quite involved because every component, as you can see on the left-hand diagram, every component that the light goes through introduces some loss. There's loss in the cable and fiber. There's loss every time you have a connector, let's say on the ODF in the cabinet or connecting to the device in the home. Every time you have a splice connection, that's the fusing of fiber to fiber, cable to cable, there is a small loss of imperfection when you fuse the fibers together. And then, of course, when you split the light, every time you split the light 2 ways, you're halving the power. So, depending on the number of splits, the number of homes you want on one fiber, the number of splices you have in the network, the length of the cable, affects the distance that you can deliver the service over and still have both ends be able to recover the signal. And the diagram on the right shows you for various splitter ratios and acceptable losses on the line, what distances you can deliver. And because of this, there are a number of different classes of optical technology, depending on the sensitivity and the power output levels for both GPON and XGPON. The more expensive ones being more sensitive and allowing you to deliver longer distances. So that's the technology. The infrastructure that we're going to deliver it over, the poles and the holes. The civils infrastructure, we've talked about the splice enclosures, mainly located in chambers. You see bottom left, that's an example of the splice enclosure we saw connected on its mounting bracket. The splice enclosures can be on poles as well if there aren't any chambers. But typically it's the CBTs or the distribution points, the connectorized block terminals that are on the tops of the poles that have the connectors on that allow you to drop the final fiber to the property. Alternatively, if it's an area that's not delivering its legacy services using the copper service by poles, it's delivering it from underground. We have a thing called a Toby box, which will typically be put in the pavement at the periphery of the property, where we can deliver the fiber and the connector underground and then add the final drop from there. But things are not that simple. When you come to use the civils infrastructure, there are problems. There are challenging chambers. You take the lid off a chamber and discover it's full of dirt, full of soil, can be very compacted. Even if the chamber's not full, the ducts can be full of silt or broken and damaged. The chambers can be flooded. The chambers can be locked. They can be damaged at the bottom left. And an interesting one here, some people have even put tarmac over them in the past, and they've only been found with the aid of magnetism. And finally, the chamber under the fence. These are problems that you encounter when you come to use chambers. Similarly, problematic poles, overloaded poles, poles that are defective, either through rot or damage. Many poles are damaged by traffic accidents every year. Leaning poles, and finally, overgrown poles that are going to take tree surgeons to gain access to. So we've seen the technology that needs to be deployed. We've seen the assets we're going to deploy them on. But how do we make that happen? We need processes and tools to do this efficiently. First, there are a number of organizations that the ISP has to engage with to make this happen. The ISP is only going to build once, so he doesn't need to invest in all the expertise in-house. It's only going to be for a 12, 18 month, 3-year program, whatever his build program is. So he is going to engage with design consultants, equipment vendors, project management, legal counsel to deal with all the contracts. In terms of building, he'll need to use external civils contractors to dig the holes, lay cables, pull cables, climb poles. Sometimes poles are needed to replace existing BT poles to supplement them, or because there are no poles there in the first place. So you will engage with pole teams that have the equipment to drill holes in the ground and install the poles. For all that to happen in the streets, you need to engage with traffic management organizations who will deal with road closures and traffic lights and road restrictions. When you're deploying aerial cables in rural areas, you frequently find nobody's visited those poles and cables for many years, and the trees have completely overgrown either the pole or the root of the cable. So in order to deploy new cables, we have to employ tree surgeons to solve that problem. And before any of that can happen, we need to engage with survey contractors to go out there and investigate what's really going on. And finally, the most important part here is engaging with BT and Openreach if you want to use the infrastructure or the electricity distribution network operators who have electricity poles that may also have telecoms infrastructure on them that they share. They're called the joint user poles. So those are all the participants in the total project view. In terms of delivering the project, it needs to be managed in an organized fashion. And the process that we follow is taking the inputs from the business model that identifies the target area footprint. It identifies the target list of what we call the UPRNs, the unique property reference numbers. For those of you who don't know, every property, building, apartment, even I believe bus shelters has a property reference number allocated by the council. And that allows us to uniquely identify it for the purposes of doing searches and passing information around between organizations. You also need to decide where you put your cabinet head end in order to efficiently hit that target footprint. Those inputs go into what we call a high-level design process, where we identify from the geographic location of all the target properties. We work out an indicative route, the best fit route from a desktop theoretical approach, where we think the backbone, the spine or the laterals should best go down the routes, the roads, and where PIA BT assets are available, and where we want to potentially deliver the nodes on that infrastructure. So the splice closures and the DPs and where the splices might go. That's planned theoretically as a high-level design that then feeds into a survey activity, because we need to go out and confirm whether the location of the PIA assets, the poles and the holes and the ducts, are where we think they are based on databases that BT make available to us. And we need to assess the quality and condition and available capacity of those assets. That might mean that we need to, from what we learn in the survey, identify where we want to put new assets to get around problems. We might even do an intrusive survey to work out how much capacity is in a chamber, for example, whether there is room to put a splice closure. And we may or may not at this point initiate the test, what we call test rod and rope, which is pushing down flexible rods down the ducts to confirm they're not damaged or collapsed or silted up. That we start the approvals process for both application of traffic management to the councils and also potentially way leaves applications to landowners if we need to put new chambers and new poles somewhere. When we have signed off that the survey has confirmed the update to the design based on what we learnt, we will then go forward into a low-level design where we will work out where the cables need to go, how much fibre needs to be in each cable section, where the cable runs, where the splitters are, and finally work out the optical budget, how much optical power we've got and whether the distances and the splices will allow us to deliver sufficient power to the home that the ONU in the home can read the laser signal. We then, when we've confirmed the design, go into a generation of build packs, which are the instructions to the civils engineers and everybody else that's going to go out into the field to build this. Give them the bill of quantities of all the devices and equipment they need to go out and materials. And the build packs instruct them how to deploy, configure, install, etc. And then generate splicing information, which will tell people engineers which fibers and which cables to splice to which other fibers or to which splitters. So all that documentation is generated and fed into the build process, where we build and at the output of the build, we will then run tests on the fiber. So the results of the fiber should align with the optical budget calculations we've done. There should be a quality audit that the equipment that's been installed is installed to BT's approval, because it's their facilities that we're using. If there are any variations required in that deployment because it wasn't as we thought, then we can generate what's called an as-built document, which identifies the variations from the instructed design documents. At that point, the network's ready to go live. We can turn the equipment on in the head end. The lasers can deliver the GPON service down the fiber, and the DPs are then ready to receive the last drop connections as and when individual customers sign up to take service. And this is called the lead to cash. And there's an incremental process because customers don't all sign up to service at the same time. The tools we use to support this process are geographic information systems that allow us to understand where all the properties are, where the streets are, where the PIA assets are, and where we want to deploy our equipment. This is a database-driven tool that is built up from points and lines and polygons. So points are where you have the poles, where you have the chambers, where you want to put passive devices. The lines are where the ducts are and where the cables are, etc. And this information is plotted in a series of layers. If you're familiar with photography, you might use Photoshop, where images are modified in layers. And we do the same thing in the database tool, where we have layers for the road maps, the properties, where the chambers are, where the poles are, where the ducts are. So there'll be a layer for each one, and each item in that layer can have attributes associated with it. And once we've plotted all this information onto the system, when we get the survey results back, we can then add the results of the survey, what we learn about those items, as attributes in the database, as you can see bottom left. There are a number of commercially available and open source tools. One you might be interested to investigate is one called QGIS, which is a open source, very popular, and very flexible. And there are a number of different data formats that are used by different tools and different organizations. Shapefile, which is a binary file format, and KMZ, which is an XML type format. Survey tools, we use software clients on either phones or apps when we send our surveyors out that show them a a geographic plot of where we want them to go, what we expect to see, and there are a series of questions and answer forms for them as they are led by the nose, visiting each point of interest, a pole, a chamber, whatever. There are a series of questions that they have to complete so that we can assess the quality, capacity, etc. Of what's out there in the real world to influence our low-level design. And these parameters that are learnt from the survey are captured in the GIS tool and available for everybody in the business to use. And that finally brings us to the last part, which is bringing it together and building the network. So we've got our build packs and we've got our bill of quantity for materials and equipment, cables, etc. And the civils teams go out, build this, and then as it's built, installed, commissioned, tested, we talked about the as-built, where we discover that in the process of building, we come across problems and we have to create variations in the design. We can feed that back into the central offices, the design people and the build pack people to ascertain what the best fix is to the problem. And when that's worked out, provide a quick update so that the deployment can continue as swiftly as possible, and that we've captured the change. So it wasn't just guys in the field doing their own thing to fix a problem. We've captured it. We understand what the network's really built like. So that is how we get to the point where we have built, we tested, and we've enabled the service ready for the final customer drops. But as part of all that, we have, as the process has been going on, collecting data in terms of quality audits, statistics on performance, and those are fed back into the main database so that it can provide us with improvements to our process, our costs, and our time to delivery. So that's delivering the network. So finally, we have been talking about the converged drivers that have fueled the market, and you've probably noticed there's lots of activity going on in the streets, and there's a lot of promotion going on the internet, lots of new service providers springing up, all wanting to build networks. We've talked about the technology, starting as the first stages of broadband with ADSL, and then the demand for faster service through VDSL, and finally to PON, and the three variants of PON that you should now have some understanding of. You understand the two active components in the head end are in the home and how they talk, and more importantly, the magic that goes on with the unpowered equipment in the poles and the holes and the cabinets, the optical distribution frames, the splice closures, the DPs, how the fibre trees are constructed and what the splicing, the splitters are implementing in terms of optical budget and loss. And then you now should have some understanding of the civils infrastructure and the assistance that OpenReach give to the market in order to create more capacity, more competitive pricing in a regulatory framework. And we've also illustrated some of the challenges. It's not an easy task going out there delivering to some of these assets that have not been touched for many years out in rural areas. And then finally, making it happen, the organizations, the processes, the tools, the project management of the on-the-ground activity, which is a very complex and time-critical process. And then finally, to happy customers being finally connected to a live network. So hopefully that was of interest, and I'll hand you back to Andrew.
Hello, right. I will thank you very much indeed, Carl, for the talk. I know that some people have been having problems logging in, and I hope those who had problems, I apologise for that. In fact, I've had a similar problem because I run a second computer on events like this, so I book myself on these events as a normal member of the public, and I like to check that it's going out. And I was having tremendous problems before he started trying to get something. I thought of my laptop playing up, but other people had a problem. And what you have to do is manually go into Zoom and then manually put in the passcode. If you've had to do that, thank you for persisting. Apologize for the problems. I will be referring it back to the IT's technical team tomorrow, because it's not something we want to have happen again. It's the first time I've hit this problem before. So otherwise, I must try to put out some sort of all stations email. So apologies for that. Carl, we've also learned how we can get a full screen presentation. Somebody very kindly put in, I just say the words, but somehow if you're running two screens, you can pick up the wrong screen. Have you got two screens open in front of you?
No.
Okay, but there's an option, obviously, about how you share your screen. And I'm ignorant to this, but again, I better find out for another event. But apparently there's some option where you can start sort of seeing the now next slides in your PowerPoint, which is what we were seeing, which is great because we could be ahead of the game. Anyway, thank you to everybody who's put up suggestions. You may have seen, if you look at the chat line, just before we go to questions, if you look at the chat line, I have put on the link to the IET survey. I believe it's open to everybody. Somebody asked, do you have to be a member? As far as I can see, it's an open site. So it tells you I haven't yet filled out my survey, but I believe anybody can express their opinions. And the other thing, I've put the CPD certificate is attached to a blog on the IT Bucks website. It is there as an attachment. If you go to the blog, you see it says CPD certificate, and on the right hand side of the blog there is actually an attachment. You just download it. Okay, Carl, one thing just before we ask a question, a number of people said, could we have the slide pack, please? Would that be possible?
Yes.
Okay.
Yep.
All right, that would be great. If you send it to me, I'll get it uploaded. So everybody who'd like a copy of the slide pack, it will be put on the IT Bucks website. You'll have to go there and find it. It may be attached to the blog. I'll just have to look. But if you look around, if it's in the files section, I'll put in the blog. Please go here to get the slide pack. And if you want to look at the videos later on, it will be uploaded in about 3 weeks' time. All right. Okay. So quite a number of questions coming in, so we'll canter quickly through this. An interesting one, I'll feed this one forward because this I do recall this one. This is from Derek Waters. About 20 years or more ago, there were well thought out proposals for fibre access to premises using the sewer network.
Yeah.
He puts this would avoid a lot of digging. Yes, that's probably very true. What happened to those proposals?
I do recall the idea was that you would actually start feeding the fibre from the property end and follow the direction, the flow of fluid, and hopefully the cable would draw itself out into the sewer system. You intercept it further down the line. I can't remember the company that was proposing that, but actually the techniques that we now have available in terms of blowing fibre and pulling fibre, and the reduction in the cost of deploying because of the use of existing assets rather than building new, means we don't need to do that. Those were proposals when the only option, if you wanted to deliver fibre and you were not BT, was you would have to dig your own ducts and deliver your own cable all the way from wherever your active equipment was. And those are long distances and it costs a lot of money. But now, because the regulator has got Openreach to agree to allow us to use their assets for a license fee, obviously, then it makes it far more economic to use those.
Okay. A question a number of people have asked, and the first one comes from Peter. Does the exchange provide the power resilience to the OLT cabinet, etc.?
No, typically when you actually look to site the cabinet, you are looking obviously to find the optimum point in terms of distances and reach to your customers, potential customers, but you are also minded to be looking for a source of power, because if you have to get the power company to deliver it a long distance, that's quite expensive. So typically you will site the cabinet where you can see, or where you know there are either overhead power cables where you can have a drop, or else you know there are power feeds underground. And typically you would also in the cabinet have uninterruptible power supply, batteries, in case you lose the power. But also you sometimes actually have meters installed in the cabinet, so that you can go either metered or unmetered. I'm not sure of the commercial agreements in place, but yes, the power is taken locally.
Okay, with a UPS, which is a sort of feels the sort of engineering solution I'm most familiar with, and it sort of seems to have a ring of goodness until all your battery packs fail at the same time. Of course, you bought them at exactly the same moment, they have the same life. But anyway, that's a different matter. Okay. No, somebody. Oh yes, this is somebody who's anonymous, but 3 people like this one. The anonymous says their village, it doesn't say where in the country this is, but my village recently had a fibre network installed by GigaClear, which utilises blown fibre technology.
Yes.
And I assume this is blowing it into ducts. What benefit does this confer on the network builder?
So if you have duct or microduct available already in the chamber, so when we talk about ducts, actually, this is not necessarily just a duct as in a 4-inch pipe. You might actually have microduct or subduct running inside it that's quite narrow, a few millimeters, and then you can actually blow the fibre down that with compressed air from one end. And that's quite an efficient method of delivering fibre, yeah. Okay. But you have to have the facility to do that.
Yes, okay. And this is a related question again from another anonymous attendee, although of course it may be the same anonymous attendee, I can't tell. There's a problem with people being anonymous. Anyway, my house is served by a directly buried twisted pair cable. If this person wanted FTTP, would that mean the infrastructure provider would need to dig up the garden to lay a fibre cable?
Yes, yes. So this is, if you remember the slide with the funny shaped box chamber called the Toby. What the infrastructure builder, the service provider, will be doing if there is no aerial access, he will be running down the pavement with his own duct and then inserting Toby boxes at the entrance to each of the properties that he's passing, and sometimes he pre-installs the cable to the Toby box and coils it round, ready with a connector for the last drop. Or sometimes you might just put microduct and blow the fibre down to the DP in a chamber further back. But certainly, yes, exactly what you're saying. When they deploy the Tobys, they will deploy a Toby to the curtilage of every property that they're passing, and then wait for the client to sign the contract. And when they sign the contract, they will send out the lead to cash team, who will then dig a little trench and install a duct up your garden path, along the side of the garden path, to your property, drill a hole in the wall, and then blow the fibre from the Toby through into the property, and then connect that to the ONU.
Okay. I mean, I have to say I'm slightly surprised they actually dig up the garden, because I know when some of the utility companies, electricity and such, like use sort of tunneling devices, let's say call them moles.
Yeah.
And they build their own tunnel and then they pull the cable in afterwards. I mean, when they're putting replacing overhead electricity cables into properties, they seem to use that. And I think sometimes the gas, they're often when they're putting plastic, they're putting it into cast iron, and they seem to be able to put effectively a plastic liner in. But why not use a mole system to?
So first of all, it's expensive, and the reason they are using moles is because there are regulations for different types of utilities as to how deep they have to be buried to be safe. So gas and electricity, respectively, have to be quite deep, so that anybody with a spade in the street, in a garden, any digger in the road is less likely to hit them. Whereas a telecoms fibre cable, it doesn't really matter, certainly in the property, how deep it is. And if you're getting from the front gate to the front door, hopefully there's a garden border running along the path and you can bury it in the border very easily. You tend to have problems these days where people have block paved their entire front of their property, so that becomes a bit of a challenge. But certainly they wouldn't be using underground molding now.
Yes, I can see where I live. Yeah, there's a lot of paving over front gardens. Flowers are a rarity these days. No, you said Phil Cobbishley, who we earlier on said hopefully we'll be seeing face to face later on this year when he talks about what follows 5G. And I can see his question. I don't know whether you regard this as hard, but anyway, Phil's trying his best probably to ask you a hard one. Anyway, and I've got to remember my periodic table now because he's put it in, he's used chemistry abbreviations. Anyway, many new properties have copper pairs fed underground. In these cases, the planners will not allow overhead wires. Phil, thank you for so many little acronyms being thrown in. I'm trying to translate as I go. Is there a movement towards radio hop from the end of the fibre, or perhaps reuse the last few meters of buried copper cable?
Not that I'm aware of, and I suspect it would be quite expensive technology, actually. And where do you put the radio kit for the last hop? Because you then suddenly you have to power it. The beauty of PON is that you only need 2 points for the power. One is the cabinet, which is a highly aggregated thing, and you can locate it close to a distribution network operator, electricity company. And the other power source is actually in the customer's home, because you're getting the customer to power the device for you. Unlike in fibre to the cabinet or fibre to the DP, which was a potential technology that was suggested as a faster than a thing called G.fast. That would mean powering devices at the top of the pole. G.fast was ruled out as you're just trying to wring out the very last bits of capacity out of a piece of copper, but you've not solved the real problem. And you really want to manage a lot of devices at the tops of poles that are active electronics.
I think Phil will have to try harder, because I could have probably answered that myself. It certainly doesn't sound a neat engineering solution to put more electronics just on the last few meters of copper. And I mean, after all, the point is to try to get rid of that last bit of copper. A question from Rosemary, which is a slightly different slant. What are the economics like for adding a single fibre off a pole or in a street? And she's asked a supplementary, do you need to sell a high proportion of the split to make this economical?
Yes, you do. Short answer, yes, you do. But that answer is based on the economics of consumer customers. One thing we didn't touch on, because I tried to keep the technology at a relatively simple level. The OLT equipment in the cabinet isn't just capable of delivering a PON point-to-multipoint service. You can also equip the circuit boards in there with a point-to-point Ethernet service, as you would to a business. So actually, you could, if you've got business communities in a village, or a rich gentleman who's running his business out of his barn, he might actually take a whole fibre, and one of the fibres in the cable is a point-to-point Ethernet, and he's not sharing the capacity with anybody. So that does happen, yes.
Yes. Okay, I understand. In fact, I know somebody just across the road from me who runs a small business has actually had, not BT, run a fibre in from down the road. They had a tremendous fight because one of the ducts had collapsed. But when I chatted to the guys, because I could see them fighting it, and they said, "Oh, we're running a fibre directly into this premise." And so it's obviously economic, I suppose, for a small business, a small consultancy to pay for that. And I can imagine they're uploading large files. Right. The question from Alan. He asked, "Do you pressurize the cable to keep waters out?" I'm not quite sure which cable, but I know in the days of copper, they used to BT pressurize the cables, don't they?
Yes, they do. That's an added complication. There's also some of them have gas detection as well. If they're close to gas mains, the last thing you want is accumulation of gas in your telecoms ducts, and when somebody lifts the chamber lid, you generate a spark. So yeah, there are frequently seals as ducts come into the chamber. There'll be a seal around the cables to stop fluids, gas, etc. But that doesn't stop, of course, the fluids getting in along the duct rather than from the chamber.
So, but are the actual fibre cables or the sort of bundle, which I assume is an overall sheath, are they pressurized?
No, they're not. No, the cables are in the duct, and it's actually the duct that's pressurized. Yeah.
I see the pressurized. Oh, sorry.
Yeah,
pressurized ducts now. Yes. Okay.
It's the duct that's pressurized, and then there's a pressure sensor at one end. It tends to happen more towards the exchange end of the infrastructure, where the ducts are bigger and there's more cables, and there's probably more infrastructure close by to the ducts.
Okay, understand. A question about, and you may have covered this, and I apologise if I didn't pick up on this either. Obviously, you've got up and down links.
Yep.
How are the up and down links separated?
Yep. So there was in one of the slides, there was a spectrum chart at the top left of the slide, and in that it shows you there is a different wavelength for the upstream and the downstream for GPON at 390 and 410, I think. And then for XGPON and XGS-PON, there are different wavelengths. So that, first of all, within a technology, the up and the down are a different wavelength, and reflections of energy don't interfere. And it also allows you the coexistence of both XGPON and GPON on the same fiber, because effectively you're running four different wavelengths. Yeah. In addition to that, and we didn't touch on it again to keep it simple. We touched on the testing of the fiber network as you completed the build. So you've done all the splicing, and everything should work chickadee-boo from the cabinet, from the ODF, the frame, the optical distribution frame, to the DPs at the tops of the poles. But before you go live, you need to confirm, A, that you've connected the right fiber to the right fiber according to the design plan, the splicing configuration, but also that all the splices are good splices with the minimal of loss. Because if you don't get a good splice, a good fusion of fiber to fiber, you can increase the loss. So what tends to happen is you have a light source at one end. There's two ways. You can have a light source at one end and a detector at the other, and the guy that's done the splicing will actually test the light levels to make sure they're within specification, i.e. what you were expecting based on your optical budget calculations. And another method is you just put reflectors on one end, and you shine the light down the fiber, and you get a reflection back. So effectively you get double the loss. So then you can confirm that's correct. However, that's just for commissioning the network. Once you go live, you also have the option of doing that as a nightly, weekly, whatever routine. So you can confirm whether there's any degradation in any of the connections over time, particularly in these inhospitable conditions down in watery pits, what have you. You could have leaks into a splice enclosure, for example. The seals have failed, and you get water ingress into the closure. So actually, again, if you look at the the spectrum diagram on the slide, there is a spectrum allocated for a thing called OTDR, optical time domain reflectometry. So you can shine a very short pulse of light from one end down the line, and you get, for each point where there is a loss, a splice, a connector, whatever, you get a slight amount of reflection. And in time, you can see those reflections coming back at various times, depending on how far the pulse had gone before it reflected. so you can check the condition and you can do it routinely. So you can either you can test it when you build, or you can go to the expense of having routinely in a live network.
Okay, I'm aware of time's ticking on. I think we'll ask. I'll ask you one more question, Carl. What will happen is all the questions will be transcribed by, I don't know how, I assume somebody isn't sitting there with a quill pen. What we'll do is we'll send them to you, and any which you don't recall answering, we'll ask you nicely, would you mind just doing the one sentence? And we will post those as well, because I appreciate that although I've tried to be fair in the questions I picked up, I undoubtedly will have missed out some, a burning question or something, just because I've jumped over it. So unless Phil Corbishley suddenly pops up and asks you a really difficult question, and I will keep an eye out, Phil, if you are still on the call.
That's what friends are for, yeah.
Yeah, indeed, yes. Embarrass their other friends. Yes. This is from John H. This is it feels heartfelt, actually, but it must apply to quite a lot of people, particularly where I live with a lot of blocks of flats now. John H. says, I live in a leasehold flat. The freeholder will never give permission for, putting fibres in and tacking things up the walls or whatever. Do you believe that fibre will ever become a legal entitlement, so that for flat owners, in much the same way as legally you have to provide water, electricity, and gas connections?
So I hadn't considered that, but I suspect it will come, because the advance of applications and the demand for teleworking and the fact that the government want this to happen, they probably will have to force the issue, because a landowner, a property owner, shouldn't be able to hold his client to ransom over a utility, which should be available to everybody, because that's, after all, what we're trying to achieve here: full fibre for everybody, rather than being limited to fibre to the cabinet and using the last 300 meters and being restricted to an 80, 90 megabit service. It will not be sufficient in 5-10 years' time.
Okay, well, thank you very much indeed. Thank you, Carl, for answering the questions and for a very interesting talk, and it was certainly what I was hoping for, which is a sort of a peek behind the scenes. It's all very well people saying fibre to the premises, but I know from my own personal experience, not doing fibres, but people tell you things are so easy. Then when you get into the doing it, you suddenly discover it's nowhere near as easy as that. Hesitate to say that politicians often come up with very simple answers, but they sometimes do. Anyway, Carl, thank you very much indeed for an interesting presentation. I say the video it has been recorded, at least I'm keeping my fingers crossed here, and it will be uploaded about 3 weeks' time. Slides hopefully will get within the week, and the Q&A perhaps in the same time. I'd like to thank everybody who's watched the video. Apologies for the problems some people have had in logging in. That will be pursued, because something's gone wrong in the link that was sent out, which is very aggravating. I appreciate if people are trying to join in. Carl, thank you very much indeed for giving up your time. And I hope we can persuade you perhaps to come to High Wycombe in the future. Not on the same day as Phil necessarily, but you may wish to come and grace Bucks New University's main campus and give us a face-to-face presentation.
Thank you for the invitation.
Okay, well, thank you, everybody. I'm going to stop the recording now, and I'll just be saying goodbye to Carl, but that will be live mic, so we'll have to still mind our P's and Q's. Anyway, thank you very much indeed, and a very good evening to you all.